who had asked the question also, or shall we not keep that?
If you had the name.
Names would be nice. We can wait for some time. Yeah.
I mean, I do have the names. Should I paste it again?
Yeah, question and name, question, name. Can you do that? I'll just, if you can share the link, I can just directly.
If you when you read it out, if you put a name, it always helps.
Yeah. That's so and so.
Are we live, Sandeep?
We're not live yet, I think.
Not yet. Okay. Matrika, over to you, start.
We're live?
Yes, we are.
Okay, great. Hi, good evening, good afternoon, or good morning, wherever you are. Hello, everyone. My name is Matrika. I'm one of the TAs of Energy Resources Economics and
Environment.
And environment. Sorry, I
Yes.
missed that one. But hi, everyone. This is Matrika. I'm one of the course TAs, and with me are my course TAs and this main course instructor. If they would like to introduce themselves, a little bit about me. I am a PhD scholar at IIT Bombay, and my research is related to sustainability and climate action. We have Pratik and Chaitanya. Pratik, would you like to go next?
Hi, this is Pratik. I'm a PhD scholar also. I'm doing research on public policy. I specialize in renewable energy policy. So, Chaitanya?
Yes. Hi, I'm Chaitanya Kole. I'm a final year dual degree student in the Energy Science Department at IIT Bombay. My interests lie in the area of renewable energy and microeconomics. I'm currently working on the response of Indian electricity market to renewable energy penetration.
Thank you, Chaitanya and Pratik. Before we go to Professor Rangan Banerjee, I'd just like to go through a rundown of how this session is going to proceed. We had already shared with you a link in which we had asked you if there are any questions that you have, and many of you have submitted some questions. So first, we are going to go through those questions and try to answer them. After that, Professor will be giving a small presentation on the current scenario in the energy sector. And then if there are any more questions, you can put them live on YouTube, and then we're going to address them. I think I've covered that all. So Professor Banerjee, it's your table now.
Yeah. Good afternoon. My name is Rangan Banerjee, and I recorded the course that you have registered for a few years back. At that time, I was in IIT Bombay. Currently, I've shifted from IIT Bombay to IIT Delhi. And today, we will basically, this is a live interaction. And I will also, since the recordings have been done a few years back, there have been many changes at the national level. And I would like to just quickly go over some of those, especially what our Prime Minister has committed to in COP26 at Glasgow recently. So we will do that, but first we will take the questions that you have already asked, and we will try and answer those questions, and then you can also put questions on the YouTube channel so that we can address that. So this, we have roughly about an hour for our interaction. So let's go ahead. Matrika, over to you.
Sure, sir. So the first question is by Dhyanchand Nayak, who wants to know more about DC system by using solar panel. That's his question. I think he wants to know more about how DC systems work using solar panel. If you can address that, sir.
Okay, so of course this was not the this is not the focus of this particular course, and you can have more details on it in the in other courses related to photovoltaics. But if you see in the PV panel, the output is basically DC, and we couple a number of panels together, and then because most of our electricity supply systems are AC systems, we usually have an inverter, and then we take that inverter and convert DC to AC. But it is possible to have the DC system and couple it with DC loads. And many DC loads are there, and you could have a completely DC based system. And there are examples of this already in operation. You may want to look back at the first initial grid which was there. Edison's grid was a DC grid. And then, of course, after that, what happened is, because you wanted to have large, interconnected, centralized things, we moved from DC to AC, and then finally, everything is now gone AC. But it is possible in the case of PV to have DC-based supply systems. Pratik has had experience in actually installing and looking at PV-based systems. Maybe he would like to give you some practical inputs. Pratik, would you like to say anything on this DC PV and DC grids?
Yeah, so basically in India, what we have is what solar panel produces a DC system, and then we convert it to AC using inverters. So in large scale plant, we have inverter unit for that purpose, or say power electronics unit for that purpose. So in rooftop system, or say in small plant also, we have inverters if it is like 1 kilowatt or some system. And if you have micro system, or say for home appliances, there are appliances which directly use DC now. So you can completely have a DC system with your solar panel. You can run few appliances like fan and TV like this today with that system.
Okay, let's move on. If there's any supplementary question, please put it on the chat. Otherwise, we can move on to the next question.
Yes, I think let's move on to the next one. This question is by Mr. Hariram Hare, who is a faculty at a university, I think. And his question is how to memorize all the mathematical formulae which are being used in these lectures, because of course sometimes it becomes difficult. Professor, would you like to answer that?
Yeah, so the simple answer to a question, don't memorize this formulae. Don't memorize the formulae in the... so if you're bothered about the test, in the NPTEL test, we have a formula sheet which is given to you. Normally what happens is, if you do a few examples and you do some examples, some of them automatically stick in your head. And in some other cases, for instance, we're talking of capital recovery factor, etc., you can actually go step by step and derive it. It's just a 2 or 3 step process. So the thing to do is, let's get away from this memorization business. But yeah, you need to know some of these formulae. You can have it handy when you're actually solving any problem. You can always look it up. For the exam, we will give you a formula sheet. And in general, if you do a few more examples, some of these will stick in your head. So that's my answer. Please go ahead, Matrika.
I think it's an associated question related to that from Aryan Khanna, who is asking how to prepare for the exam. Will the assignments and lectures be sufficient for the exam, and what is going to be the pattern for the exam?
So the pattern is quite, the exam is patterned, and we don't want to test what you don't know, because that is always easy. We can always set a paper which does that. But we want to test that, have you gone through the material and if you understood and you are doing the basic calculations. So if you do the assignments and the questions, and then we have also, if you see, there was an exam which we have solved in in some of the recordings. It's actually reasonably patterned, so I don't think that should be a problem. Yeah, so don't worry too much about it. And also these are all, they're all either MCQ, or there are things where you have to actually make some calculations and do that. I think should be all right. People have usually done reasonably well if you have gone through the material.
Yeah.
We can also have, if you have, before the exam, if you have doubts and if you have some things, we can always create either an online help session or even a live help session. That can be done. We can do that. The problem usually what happens is, many people do look at the lectures, but they don't always too much engage with the course. So if you're engaging with the course, I don't think the exam should be a problem. Go ahead, Matrika.
This next question is by Ranganathan Rama, who asks, Professor, whenever development projects are being assessed, how do we include the cost of long-term health? For example, nuclear energy is definitely a greener option. So how is long-term health considered when development projects are concerned?
A short answer to that is, it's not considered. Longer answer to that is, typically what happens in all of these is that we usually do the cost benefit analysis in terms of economics. And when you look at other impacts, positive or negative, which are not coming into the economic framework, these are typically tackled in terms of externalities. So in many cases, what happens is that we have some constraints in terms of saying that, okay, emission should not be more than this, and things like that. So if there is a quantifiable long-term health impact which is adverse and people are able to study it, and then you can do that, then you can actually rule out certain technologies. The problem which is there is, you talked about nuclear and radiation typically what happens is, in the case of nuclear, you have some exclusion zones, and the issue is with normal operation there's not much of a problem, but in case there's a low probability of an accident, but if there is an accident there is a high probability of damage, and this is a societal thing of how do you relate this. No easy answers on that. No easy answers on that. There could probably, I think you may have supplementary questions, you can put them on the so there's a whole area of research where you try to quantify health impacts, put it in financial terms, put it into your cost analysis framework. Yeah, Matrika, go ahead with other
Yes,
questions.
sure. I see that Ranganathan is there in the YouTube live session. So if you have any questions about that, you can please put that on the chat. I'll move on to another question by Kaushal Kalu, who has two questions. The first question is, one often hears of different projections of falling costs of renewable energy investments. Can you situate this in an economic framework and discuss what are the factors responsible for the same?
Yeah, actually, this is a nice question. It's you can actually see this. So look at see what happens is, in general, as we try and do something and we do it a second time, we learn how to do it better, right? And because of that, we are able to actually make the same thing with a lower cost. So what is this is covered in theory called a learning curve. And learning curve, typically what happens, these are experience curves, so that if you scale and you do a large number, your costs can come down. And this is this learning curve effect. You will see in PV, it says that if you double, what is the learning rate? And in many of these cases, if you look at fossil, that learning rate is almost stagnant, so there's not much reduction. But in an early stage technology, there's a lot that can be done in terms of learning, and this is all within the same technology concept. You could also have a breakthrough where you actually go down in a different cost. So you look at PV or you look at wind and you plot the cumulative cost, the cost per, let's say, cost per kilowatt or cost per megawatt, and you take it with the cumulative amount of PV modules built right from the beginning. And when you do this, you find, and you take a log scale, you find that there is a linear relationship. There are some very interesting papers on this, and you can see these learning curve effects. If you, I think we can offline, we can send you some of those links. So if Matrika or
I will do that, sir. I will do that.
yeah, please do that, because this is quite interesting. So conceptually what happens is that, see, if you do more of it, you learn how to do that better, and you compete, and then the costs come down, and so there's a technology improvement. There could also be an economy of scale, and some of these are not, of course, scale neutral. So from your question, in terms of an economic viewpoint, this is the way in which that happens. And I think yeah, there is quite a bit of theory and literature which shows this, but it may not continue to go down. It might, at a particular point, it might actually stagnate, and it may, so it's like, we started off, for instance, in the case of PV, we started with 12 rupees or 11 rupees, 12 rupees per kilowatt hour. Now we've gone down to less than 3 rupees, but it doesn't mean that it will keep going down. There will be some limits based on fundamentals of materials, fundamentals of technology, and so it may actually go like this, and then go asymptotically to some value. What is that value? We have to sort of figure, because essentially what we are doing is we are taking some decisions which impact the future, and we are taking decisions on it, and these costs keep changing. And the learning curve effect is experience curves and learning curve. There's a lot of literature on it, so if you're interested, you can look that up. Yeah. Back to you, Matrika.
Sure, sir. There's another question by Kaushal again, and
Yeah.
it is: do you think the recent government order imposing customs duty on imported PV modules and cells will hurt investments in solar energy?
Do you think what was the last part of it? Do you think
Uh,
the recent
do you
government
think the customs duty will hurt investments in solar energy?
hurt investments? Okay.
So,
So,
sir, from 1st April onwards, India has imposed 40% import duty on solar panel. So, I think this
yes,
question is
yes.
related to that.
So I think, yeah, I think what we need to look at is there are two things. One is that if you see our current state of development, we are a big market for PV. And if you look at the PV that is being cells and modules which are there, almost all of it is imported. And a very significant part of it is imported from China. And strategically, the national government prerogative, for obvious reasons, is we want to be in having energy security, and not just energy security, we also want to have security of the technologies which lead to energy, which means that we must have our ecosystem where we build our cells and modules and they compete. And this is why this has been installed. Put in the short run, of course, it could affect investments, but in the long run, hopefully, our industry will gear up, and so we have to wait and see. There is a dynamics, and you can see clearly there are two different kinds of things that we are thinking of in terms of strategy. I mean, it's not just about reducing the cost, but it's also about having our own supply. And this will also mean, in the job chain, the manufacturing and the first part of it also creates a whole series of jobs. And if we have that right from wafer to the cells and modules, we create a whole host of jobs in that ecosystem. So that's the goal of the government. So I think it's a reasonable goal. But in the short run, it could affect investments.
Sir, if I can add something to
Yeah,
this.
please, Pratik, please go
Yeah.
ahead. You'll have a good view on this. Yeah.
Yeah, so basically, this custom duty and all these are actually these come under the realm of international trade policy. Like a country has a power authority to have such kind of duties, and this is not the first time that these duties have been levied on solar panel. We earlier had anti-dumping duty, which is basically somewhat different. The anti-dumping duty is specifically for one or two countries. Custom duty, this basic custom duty is for all the imported, like the goods imported from all the countries. So these things actually happen, and as sir told, in short run it may hamper, but investors, being investor, they look other opportunities, and now they may look that okay, if I can shift from one type of investment, say the deployment or say project installation, to the manufacturing, so investment may actually change from one type of project to the other type of project. So this may happen.
Let's move ahead, Matrika.
Great, thanks, Pratik. I think I only partially read Ranganathan's question previously, so my apologies for that. But let me just go through that again. The question is: whenever development projects are being assessed, how do we include cost of long term health? For example, nuclear energy is definitely a greener option, but we fear incidents like Chernobyl or Fukushima, and such concerns are highlighted. It is definitely a concern, but if we take long term health concerns of continued use of coal and its related pollution, nuclear may be a viable option economically as well as environmentally. So, can you share your views? Similarly, like in case of how there's a metro car shed issue versus long-term traffic congestion issue. There's a coal versus nuclear issue. So, if you could give your opinion on that, sir.
So I think, this is an area where, yeah, coal versus a nuclear and long-term health effects. I think this is an area where there is a need for clear articulation and research. And very clearly, this is the nuclear group has been talking about it. Now, the question is societally, you have to decide on this. You see, there is, in the case of coal, there is an occupational health issue. There is also an issue where people are mining, and sometimes there are issues related to mine accidents. But there is also, in the region, there is a health issue, which is through its normal operation. In the case of nuclear, with normal operation, limited health issues because you are anyway removing it from the exclusion zone. But if there is a problem, there is a very serious problem. So there is a question of, it's a small probability event with a high probability of impact. And here there is a relatively smaller, longer term impact. So I think both are, both are negatives in that sense. And how do you compare these? There's no clear rule, but one needs to put down the risks and the costs and benefits. And then the other question which you need to ask is, who's deciding? Are we getting, for instance, if you're talking of nuclear, the people in that vicinity don't want a nuclear plant. In the case of coal, the people who are working there want their employment. The people in the vicinity don't want. So there are tough societal choices, and this is where there is a environmental clearance. There are supposed to be hearings of stakeholders. Many of these things, because of speed, are often bypassed. So this is a problem. There is no clear-cut answer which the course can provide you for these, but we can provide you methods by which you can quantify and compare, right? So I'm not able to answer your question in a direct sense. There are, depending on the weightages and the way you can do it, you can show nuclear to be better or coal to be better, but there are different kinds of impacts over different time periods with different probabilities. And this has actually quite a lot of analytical rigor. There's lots of papers, there are lots of things. This is a big area for research. There's also a big area for, after you do those results, how do you communicate it to stakeholders or to policymakers? And that's again a challenge. So this is actually, there are lots of things you can do with some of the basic things that we learn in this course. I don't know if you have any follow-up questions. Please put it on the YouTube. This is an important area. Yeah, Matrika, please go ahead.
So those were the basic questions we had on the sheets that we had shared. If
Are
any
there
more
any other questions on the YouTube before we move
on
forward?
YouTube,
So there is one question by Devansh. He would like to know the format of the final exam.
Yeah, so I think that we can share with you offline. The format is, there are going to be, I don't remember the exact number, a certain set of things which are MCQs with 4. Then there are some long answer questions which are typically for each section. We have some fill in the blanks and MCQs. That means these will also have some numericals, and we can send you those formats, no problem.
Yeah, and again there is one question: how to remember the formula?
So we can refer to the answer
Yeah,
earlier. Don't
yeah,
need to convert. Yeah, but
yeah.
you
That's
need
it
to
for
be
now.
able to see, once you have the formula, how to use it, how to interpret the results. That is more important, I think.
Yes, sir.
So
So yeah,
no
that's
other,
it for now. No other question.
no other questions. So let me do one thing. Let me see if I can share my slides. Okay. So what I'm going to do is, if you know, we talked about in the initial set of, is it not, it's not showing as slideshow? Huh? I put it on slideshow, but no, but it's not coming in slideshow mode, no?
No, it's not in slideshow mode.
Yeah, that's what's happening. I don't know why that's happening. Hold on, we'll figure out. On my screen, it was showing like that, but it's not showing on the. Maybe some setting has to be changed. Maybe we'll see the entire. Now is it okay? Yeah.
Yes.
So I just wanted to tell you, which we've talked of earlier, is we've talked about this. We in India, we've made a transition from traditional fuels to the modern commercial fuels, mainly fossil. We've done this over a couple of decades, and we've made investments typically in centralized energy supply and distribution. We have centralized interconnected electricity grids. We have had large hydro and coal-based thermal power plants. The initial focus has been on supply growth, and these were public sector and government investments. This is what has happened over the last 20, 25 years. In the last 5 to 10 years, we've been making some other changes, and you can see this. It's not showing, it's not changed. It's changed. Okay, there's a lag. So basically, what we are looking at, what is the energy transitions in the future? And you all know about, we've talked about it in the recorded lectures you would see. We've talked about the Paris commitments, climate change. There's a global move away from fossil. In India also, we've done that. There's been significant drop in prices of renewable energy, and this was the question which was asked on solar PV and wind. Reduction in prices of shale oil, natural gas. In the Indian context, we've also done a lot of public procurement of different things like LEDs, even BLDC fans, rapid decline in prices. And another trend which is there, which has not yet impacted the sector so much, is that we've had a lot of advancement in the IoT or Internet of Things, technology development, intelligent sensors, control, all of that has happened. So we would like to see actually distributed systems coming in, but not happening too much because our investments and businesses are such that it goes in the other system. So if you look at India's energy transition in the future, if you look at the electricity sector, it's the supply mix which is changing. That means we are going away from fossil and we are going for more renewables. We are doing much more of efficiency. In the transport sector, we are trying to move away from oil. This is a tough one. We are talking of electric vehicles. We have CNG mandated in many of our urban places. We have hydrogen, which is being talked about, and there's a hydrogen mission coming up. There are many other things, biofuel, methanol, again at niche places. There's a move from private to public transport, and with the unfortunate situation that we've had over the last few years, we've seen that many things that we can do without traveling. So we've reduced the demand for travel, and hopefully things have improved. But some of these lessons can go forward, and we need to really question whether really there's a need for that travel. In cooking energy, we are going from biomass and traditional fuels to LPG, and this is another problem because then the LPG is still fossil and it's imported. We can go for electricity or modern biomass. There's a big question mark over there. So cooking energy is one challenge. Buildings, we can try and see that we get net zero buildings or energy plus buildings. Each building actually becomes a generation, a point where it can generate its own energy, and the industry also can go for low carbon industry, and we have processes which are low carbon or zero carbon. So that's another thing which you can. So we had shown you earlier a sort of energy balance, and you can see the energy balance which is updated, and we will show you this for 2019-20, and you can see predominantly our energy supply continues to be based on coal. Oil, most of the oil is being imported. A large proportion of the fossil energy is being used for electricity, and then it is being used typically in residential, in industrial, and in other sectors. And you can look at something like this, which is a Sankey or an energy balance diagram, and you can look at it in terms of primary energy or the total final energy. And when we look at this, and this is something I think we had shown you, this is some updated values for this, where you see India as a compared to the world. And I think there's still a lag. It's going to show hopefully now. Yeah, you can see that we are about 1/6 of the world's population, but we are significantly, we are looking at the primary energy is just about, we are talking of primary energy, which is the final energy that is being used, or the primary energy supply, 38 exajoules out of that almost 600 from the world. So it's only about 6% of the world's, and we are, of course, on a per cap, we are poorer than the average person in the world, and then also it means that we are only, the CO2 emissions is only about 1.6 tons per capita per year as compared to a world average of 4.4. And so that means we are much lower than this, and you can of course update this to 2019 or 20, and we have been involved with Niti Aayog in one of the India energy security scenarios. There's a software. We'll send you a link, and some of you who are interested may be able to go into this. And you can look at typically 2005 and 2015. We talked about the Kaya identity, and this is something, again, I think you have already got these in the slides, but you can see some of these. It's still not come up. There's this lag. Yeah. So you can see that how we've changed in terms of carbon intensity and energy intensity, and you can see there are projections of how this will go forward. You can also look at the world energy diagram, and this, if you see, this is from a source in 2018, so that you can compare. You will find that in the world, unlike in India, you will find that predominantly we are talking about oil, and then coal is not the main source. But otherwise, you will see residential is about 1/3 of the total, and industry and the rest, it's like 1/3, 1/3, 1/3. And you can see the differences in the mix. So we talked earlier in the lectures. You would have seen India's commitments, which we made in Paris, which was reducing the emissions intensity of GDP by about 1/3 of 2005 level in 2030, create 40% cumulative non-fossil power by installed capacity by 2030, and an additional carbon sink of 2.5 to 3 billion tons. So on these, actually, we are moving quite well. And in Glasgow, uh, recently, our Prime Minister has announced a set of uh, targets which are even beyond this, and you can see that these are the targets. So you should be aware of these targets. We have made a target of having 500 gigawatts of non-fossil power installed capacity by 2030. So it ups the target which was there in Paris. And we are also saying by 2030, 50% of the energy mix would be based on renewables. There's some ambiguity about how this is to be computed, but in general, it is meant to be on the electricity side. We are also looking at by 2030 reduction of 1 billion tons of CO2 emissions, and that has to be calculated from 2021 onwards based on whatever are our CO2 trajectories, and then do this. And by 2030, India would reduce its emission intensity of GDP by 45% over its 2005 level. You remember earlier it was 1/3. Now we are saying instead of 1/3, it's going to be reduced by 45%. And the most other important thing is we have actually made a commitment that we would achieve net zero carbon dioxide emissions by 2070. So I want to tell you, and this is something you would have read about, what we are talking of in terms of net zero is that on an annual basis, the total amount of CO2 that we are emitting should net be zero. That means we will emit something, but we will also absorb something. We will have more capacity. And so basically, cumulative from the cumulative emissions, we go to a point where annually we are not adding any more CO2 into the atmosphere. And this is a target different countries have set for themselves. If you look at the IEA report, there's a 2050 net zero for the world and different kinds of targets. India, we have decided to set up a 2070 net zero. And this is from it's still coming, we just wait till it comes. This is the net zero IEA report. It's available online. Please take a look at it. This is the projected CO2 emissions for advanced economies and for the emerging economies. And then if you see the per capita emissions of the advanced economies much higher, and the developing countries go in that way. And then finally, they all go towards the same number by 2050. This is one possible way of moving forward. And in this IEA report, if you see, let the slide come, you will see it soon. You can see that from the base year of 2020, in the normal case, what would happen is we would go, it's not it, there's a lag. We'll just wait for it to come on your screens. I think it's taking more time. So basically what you see is, as per this 2020, based on the growth and based on the policies, if you have business as usual and the normal policies, we would increase till 2030, you would increase by about 24%, and then you reduce it by the combination of energy efficiency, electrification, wind and solar, bioenergy, behavior and avoided demand, carbon capture and storage. And then we go to the 2030 number. By 2030 to 2050, you would increase by about 50%, and then you can go down with all of this. So these are one possible way of moving forward and getting net zero by 2050. Okay, so this is not necessarily the way in which it has to be done, but just to show and to calculate, and then you can look at investments and things like that. This is how we think in terms of the future. This is also outlined in terms of different kinds of cumulative reduction by different technologies that give you the targets in terms of different technologies. And there are lots of, so we were involved with Niti Aayog in trying to help the government focus on how we can do the net zero. So what we did in this is, we were looking at what should be the year in which we would peak in terms of CO2, and which year should we go for net zero. And with different years, what would happen is the trajectories would be different. So we just created a simple model, and I'll just tell you the basics of the model, and then we can see. I'm still waiting for the slide to come up. So what we started with is, we looked at the time trends or the past trends of CO2 emissions, right? And once the slide comes up, you'll be able to see that. And when you look at that past trend, in the past, you will see in the past few years, when you look at the trend, you can project that growth rate into the future, and this becomes that, this is the line, the extreme line which is happening. Now, in actual practice, we have already made some policies where the growth is not going to go at that rate, and that's the next orange line which you see. And then after that, we said that, okay, we can do some amount of carbon capture and storage and some amount of afforestation. And with that in mind, we can then have things where we become net zero in different years. As you do that, we have a peak year and a this, and so we had a way to generate alternative trajectories, which helps policymakers decide which year it can go to. This is a sort of overall target, and we work towards that overall target. And so that is the way in which we calculate and work out what was net zero. You will see that many countries have got reports, detailed reports of how to go towards net zero. And when we look at this net zero, what would happen is, predominantly our electricity sector would become mostly on renewables and hydro. There might be a little bit of fossil or renewables, hydro and nuclear. And then there comes the question of storage. Cooking becomes an issue. Some of the industrial use becomes an issue, and then there is a role for hydrogen. Whether you have modern biomass systems or hydrogen, or you do fossil fuel with carbon capture and storage, all of this will depend on how the technology and costs emerge. But net zero is one thing which people are looking towards. There are lots and lots of reports and papers, and I thought it would be good for you when you look at this course. If I was to record this course now, I would talk about net zero and show this. So I thought I should just give you some indication of this. And if some of you are there on the YouTube and you have some questions, I can expand on some of these a little more. I will at this point now stop sharing and go back towards the Q&A session. So let me do one thing. Let me go back. And yeah. So I've stopped sharing. Are there any questions or comments? Pratik,
No, sir,
Malvika,
there are no
Chaitanya?
questions as of now.
No questions or comments.
Yeah.
I don't see any questions now. Shall we
Yeah.
wait for a minute or two?
Yeah. Chaitanya, is there anything you would like to add or say? Because Pratik and Matrika have been speaking. You have not heard you say anything. Anything on the net zero or anything else?
I mean, the presentation was quite comprehensive. I think I haven't actually worked myself on net zero,
Yeah.
but
So I think just to add that, I mean, the in COP26 in Glasgow, many countries had and there was a sort of move to sort of push some of the countries to make announcements on net zero, and we also made that commitment, but we said that we need some more time. So many of these other countries have made net zero by 2050, 2060, and we've taken a little bit more time to do that, because we have actually, if you see, in terms of the CO2 per capita, we are much lower than the other countries, many of the other countries in the world. And we need to also understand that all these transitions have a cost.
Yeah.
Because if you just look at many of our cities or many of our regions which are completely dependent on coal, right? They are not going to, you can't just suddenly say that we're going to switch off coal. And there are economies which are dependent on fossils. So we need to see how to, and there is this whole concept of just transitions where we try to look at what is happening to communities, who are vulnerable, how are they affected, can we retrain, can we provide alternative employment, can we provide support to these economies, and so this needs to be coming into the narrative a little bit more. And these are some of the things I know Matrika at least is working on some of these issues, and these are issues which when you are talking of energy resources, economics, environment, these are things which you need to be aware of and work on. There is a lot of potential in these areas because it does make a lot of difference. And typically what happens is whatever we do, it's unlikely that we are going to have a very smooth transition, right? So there will be some amount of climate change. We're already seeing that in terms of extreme events. And whenever we have extreme events, it is the poor and the vulnerable who bear the brunt of that impact. And so then we need to see how do you support that, and then what are the costs. And these are not costless, you see. So I think one needs to think this out a little bit.
So,
Anything
sir,
you want to
I
add?
have one
Satya?
query.
Yeah. Yeah, please.
So, sir, based on your experience, how do you see this 2070 target? Is it too easy or too difficult to achieve for India?
I think, Pratik, what happens in this case is we are sort of hedging our bets. We want to see that we have some time where we can make the transitions properly, and we don't want to be constrained. So when we looked at these, one of the things that we tried to see is that if you look at the growth, right, of the CO2, and you also look at the growth of the economy, the peaking year, and you look at peaking years of different countries in the world, and correspondingly you look at what is the GDP per capita. So actually, our peaking year, which is there, our GDP per capita is lower than, we always often compare with China. And it's lower than China, and it's lower than many of the other countries where it's peaking. So the implication is that we have a sort of growth trajectory, and then we go down. Now, it's possible, Pratik, that we may, if technologies develop, that we may be able to go zero carbon faster, right? But today, when we look at technologies and costs, we don't want to make that commitment as part of our commitment because there are costs associated with it. And then we want to develop capability to, if you're saying hydrogen, we hardly have any, we have some limited technology. If you're looking at lithium ion batteries, we hardly. So I think there is a link with development, there is a link with, there are trade-offs. And so we don't want to be, if today we tell the US or we tell Europe, that you just go down to our levels of CO2 per capita in the next 3 years or 5 years, they won't agree, right? So in a similar fashion, I mean, basically we are buying some space for us to do it's a strategic thing. And so, yeah, maybe we can do quicker, but yeah, that's the kind of thing which is.
If nothing else, I believe that this 2070 commitment at least gives us an opportunity to rethink the pathways we have conventionally
I
taken,
think what has happened, Matrika, is that there was a change, because our initial thing was that, we don't want to take net zero as a commitment, because it's an unfair world, and people are forcing us to make that commitment, but the people who are forcing us have much higher CO2 per capita. So that was the kind of thing. But then we said, given the kind of situation that is there, we want to do this, and this is something we want to do, but we want to do it at our own pace. So that's it's sort of, yeah.
Makes sense. Considering that we don't have any further questions from any of the learners, so I believe
I see Amit Jhalani. Is he from the NPTEL, or is one of the students who's joined?
everything is from NPTEL.
Okay.
So I am one of the participants in NPTEL course. I am
Okay.
continuously.
Okay. So you want to you have a question or anything to ask?
So no, sir.
Okay.
That's fine.
Okay.
Thank you
Fine.
very much, sir.
So there are no other questions, Matrika?
No, sir, we don't.
Okay, we still had another 10 minutes, but I think we can end if there are no questions.
Just to update, like we will be having more of these live sessions again. I think maybe one next month and the month after that. So we'll be putting announcements regarding that in the announcement sections of the course. So, and there might be many who might be looking at the recording session later. And if there are any questions that you have regarding the recording, you can just put your queries in the forum, and then we'll address them later in the forum itself.
We can share this PPT that I presented
Yes, sir.
today.
I think we can upload that on the forum.
Yeah, and I think before we stop, I would just like to acknowledge Balkrishna Surves, Sandeep Lavate, and Ramlakhan from IIT Delhi for helping us coordinate this, and of course, Matrika, Pratik, and Chaitanya, who are actually, I mean, I'm sort of an absentee instructor. They are doing everything. So yeah. We'll be happy to, if you want, we'll be happy to do a couple of more live sessions. It's fine. The problem in this is it's a live session in name, but it's hardly two-way, We just talk assuming someone's listening, but you don't know. Okay. Okay, Matrika, please go ahead. You can.
Yes, I think that's it for today's session. Sandeep, can we shut down? Okay, great. Thank you, everyone. We hope to
Thank
see you
you.
in the next
Bye.
session. Bye.